and policy implications, and then we can look at the conclusions. I can see it.
Can you support us actually sharing the presentation by Geoffrey? Yeah, thank you very much. It's visible.
Yes, so I was introducing this first paper, which is optimizing seed crop selection for various climate, an AI-based approach for enhancing agriculture productivity using vertical farming. I was defining some of the key terms. When we talk about vertical farming, means we grow the crops using towers. Then seed crops are crops that can be planted and replanted. And then also optimizing is getting the best. And in our presentation, we will look at the background. And the background basically starts with the climate change, which has affected the crop yields. And climate change is like AI. It's not going anywhere, but we need to have solutions that are sustainable, like sustainable agriculture that can help address that issue. So in sub-Saharan Africa, our agriculture is rain-fed. That means we depend on rain to grow these crops. But using...
Slides are not moving. IT, please help, because slides are... yes, move. Yes, good.
Okay. All right. In the background, climate change affects the crops. We have experienced it in East Africa, where we had a decline in 30% yields of the crops. That's why the prices of maize or foodstuff is high. And in sub-Saharan Africa, our agriculture mainly depends on rain. So, but with vertical farming, you only give the plants the nutrients they need to grow. That means you save more water when using vertical farming. And the critical gap here is that we need to identify or get the best seeds that can be grown under a dynamic, controlled environment. I think many people know that most leafy plants are grown using vertical farming, but in this paper, you will discover that even fruits and other seed crops can also be grown using vertical farming. So the problem here is that the traditional selection of this seed crop is static. Basically, people depend on the historical data, which actually ignores the potential of growing some of these crops using vertical towers. So this leads to optimal yields and also resource wastage. We realize that if you were to grow these crops on the land, you actually use more water. So this work basically addresses, can AI integrate climate, genetic, and farm data to recommend optimal seed, improving productivity and resilience? So our objective one was to integrate the multi-dimensional data set, the climate projection, seed genetics for the vertical farm parameters, and also develop an ensemble machine learning module to predict optimal seed varieties with high accuracy, and also evaluate the system performance through pilot implementation, which we did it for about 18 months. The methodology here that we used was mixed method, because data was coming from the IoT sensor data for the plant genetic traits and the different parameters. And we also use qualitative, because we had 3 setups where we had the greenhouse, which is not fully controlled, and then the one which is fully controlled, means the environment is controlled with the different sensors. So the analytic method, we use the ensemble machine learning. Reason being, it is it improves accuracy and it is very robust compared to other algorithms. And then the innovation here that helped us to come up with this data integration with our first objective was edition support system that helps us with the integrating or ingesting all the different variables for the plants to grow, and then also does the prediction and then the recommendation. The key results from our finding, we had a very high module accuracy because we did a lot of hyper-tuning of the different parameters. And with the root mean square error, we were able to get the ensemble root error of up to 0.92 accuracy, that is 91% on the performance of the module. Then we also had the module looking at the water usage. When you compare with the traditional farming methods, it actually consumes more water than vertical farming, because vertical farming, mainly you only provide the crops with the right nutrients, and then you use less water, and then the module performs very high. So the crop failure rate was about 67%, and also there was a reduction in terms of wastage of water as per that graph. So the implications of our findings to the science and technology innovation, one is that it helps us to validate ensemble machine learning for complex agriculture optimization, and also provides a replicable data that can be integrated in the framework. The economic transformation here is that 31% you can get higher yields when you grow your crops without actually soilless farming. You don't involve soil you only provide the crops with the right nutrients. So it saves water, because I think rainfall wastes a lot of water. So there's increase and lower operational cost. But the process is very expensive to set up a greenhouse. And then also creating jobs, because when you look at, I think this is where the science and technology innovation could come in, because it has a lot of potentials in building up the towers that are being used for growing this. In Africa, we don't have any industry that manufactures these towers, so this could create jobs for the urban farmers, because according to the report, the population pressure in urban areas is going to increase up to 68%. That means there's going to be pressure on land, and a lot of people will go to bed with empty stomachs. So I think this would be the best sustainable approach to farming. Then also on the regional integration is to enable us to harmonize the seed systems that share climate data. Many people still know that only leafy crops like kale and collards and spinach are the ones which are grown using vertical towers. But you can even grow fruits like tomatoes, strawberries using vertical farming. So also to have an evidence-based seed variety that can be released for this control environment. It's a big challenge. When I was doing this work in Uganda, we had only 3 sites that are running semi-automated hydroponic or vertical farms that mainly deals with fruits and leafy plants, but very few were dealing with legume crops. So it was our module that we use and then the data sets that helped them to believe that crops like bush beans, green beans can also be grown using vertical farming.
Geoffrey,
So
you have 1 minute to conclude.
yeah, I'm concluding. For the policy and recommendation, for research and innovation, there's need to expand on the different crops that can be grown, apart from the peas, green beans, and cowpea, and then also integrate the real-time sensors, because most of these sensors are independent. So integrating the data was a very big challenge, because you have a sensor which only captures pH and temperature. So for the private sector, this is a very big opportunity for them to invest in startups that can actually manufacture the towers, because one tower costs about $300 to $500, but if you can make it cheaper, that would be very good. Then also develop training for the youths. Then recommendation for the government to invest money at least for the agri-tech data infrastructure. And then in conclusion is that when you use the AI-driven selection, you cut the water by 31%, and then you reduce on the crop failure, because when you grow these crops vertically, all this data are being sent to the phone.
Thank you very much, Geoffrey. It was a pleasure hearing your presentation. Please take a seat. Can I call upon the second presenter, who is Emmanuel Ndaisenga, is going to present on an AI-driven solar energy monitoring system for energy efficient operation of milk storage. Please, Emmanuel, the floor is yours. Again, please make sure that you utilize maximum for 10 minutes. If you go beyond that, I will cut you out of that period, so that we have already started late. We are running short of time. Please make sure that you respect the time allocated to you. Thank you very much.
Thank you. My name is Ndaisenga Emmanuel. I'm waiting for presentation to be shown in the front. So, okay. The topic is an AI-driven solar energy monitoring system for energy efficient operation in milk storage chillers. Actually, in daily life, we need milk. So currently, in Africa, mainly in Rwanda, they are processing milk from farmers to the industry for long-time storage or usage in our daily life. So in the process, they can't use energy which is coming from main grid to move from that energy to solar energy. They have many problems. So next. It's me. See the one. Okay, good. So, oh, the remote is mine? Oh, thank you.
Geoffrey, can you give a helping hand on how to move the slides so that we don't lose time?
Is the one? Okay, thank you. Next. Renewable energy is needed in Africa so that you can keep our environment safe, and adoption of solar energy can help to reduce the cost in usage of electrical energy. And also, by applying AI, you can optimize the usage of that renewable energy. Next. The challenge behind the usage of solar energy is about its nature. You know, the solar energy in the morning, it's there, almost a maximum, and as the day changes, there is fluctuation on radiation. So sometimes the solar energy is stored in a battery, which is not also always constant to store the same energy. So to use that energy, you need a method of controlling the stability of that energy supplied. Currently, the method used are called the threshold method, which can detect whether there is a change, then they can adjust accordingly. But if you apply AI, you can solve those challenges. Next. So in milk chillers, if there is a change in temperature in the milk stored, automatically the milk can be spoiled. That's why we need to optimize the usage of that energy. Currently, they are using approach that we are being used to reduce the problem of storage, but if you apply AI, we increase the efficiency. For example, if there is a fault in the system for a long time, all the milk stored in the chiller will be spoiled. Next. So objective of this study is to implement a real-time monitoring system that will monitor the state of health of a battery, inverter, even the PV systems. We will employ AI using a model called the isolation forest. This model will help us to determine whether there is a problem in the system so that it can correct automatically the error or alert the user so that it can solve that abnormally on time. So we train the AI model using real-time data. We have a data set before. Advantage of using isolation forest is that you don't need to train the model using errors. You train on a normal status of device. If there is abnormal status, the model automatically will alert and show that the collection measures about that error which is happening. So, next. Here you can see how we can use AI model. Isolation forest is there to determine whether the parameter which are in solar PV, which are in a battery, which are on inverter are normal. If there is a change in either part, the system will be alerted, and then the system can detect whether the solar system is working accordingly in respect with the load and the shading. For example, there is a shading on solar PV, the system will know that the error which is happening is only shading is not a problem. The current approach they use is a threshold method, which is having some problems of alerting error, which is not an error. By our study, we found that we reduced the false alarm from 15 to 20% up to 9%. That is a good news because the system will be optimized at a certain extent. Thanks. Next. The findings from our study, we found that fault detection accuracy have reached to 93.4%, which is very good. Then we have also reduced the false alarm rate. If we say false alarm, this means the system can alert the user that there is a problem in the system while there is no problem. By using the AI model, isolation forest, we reduced that alarm from 45% up to 9%. So this can replace a traditional method of detecting fault. Another advantage is about energy efficiency, where you can improve up to 7%. I don't compare the energy, comparing solar energy and the main grid energy. I'm comparing the usefulness of solar energy itself. If you don't apply AI, you cannot save more than 7%. But if you include AI, you save more 7% of what you used before, which is a very good advantage. So I can add some highlight. If you apply AI, you can minimize the downtime, meaning that the system will help you to know the error before it happens, and you can do the preventive maintenance so that the downtime should be, should not even exist in some cases. Another advantage of using AI, you can know whether the system is operating normally or if there is environmental change which is happening, like shading, like heavy rains, or this, the model will understand the disturbance in the system is not the error, but is the disturbance in the environment so that the system will work normally. So another advantage of using this, we can associate this hybrid method with other method of using this method with main grid so that you can optimize the usage of electrical energy. Implication of the study, by using this method, you can leverage AI to do predictive maintenance for off-grid solar energy so that renewable energy should be used at maximum level. So economic implication, as Africa, we know many areas don't have main grid electricity. This use of solar energy will be used at higher rate. Even the main grid electricity is also costly. Almost, we know, solar energy is almost free. So the contribution of this research, we want to add another option that can help people to use the solar energy as alternative energy which save our environment safe. So the key takeaway, we need the collaboration by adopting solar energy so that we can use at maximum level by applying AI in our solar system to enhance efficiency, reduce losses, which can happen either specifically I go in milk, but not only in milk, and to ensure sustainable agriculture in energy solutions. Thank you very much indeed.
Thank you very much, Emmanuel. You have saved us 1 minute. Please take a seat.
Thank you.
Let us call for the next presenter. And this is not other than Paul Mireji, Dr. Paul Mireji, who is going to present on computational annotations of antennal genes in tsetse flies. Doc, the floor is yours as usual, maximum 10 minutes, so that you can save time for question and answer.
So I'm going to talk to you about some of the advances we have made in annotation of tsetse fly genome, and also how we have been able to establish how we can use that information to control tsetse fly and trypanosomiasis in East Africa and in Africa in general. So I'll begin by giving some basic background information about the fly and the technology, because I assume that probably not everyone here is familiar with this organism and the technology. So I'm going to talk about it in the provided schedule, from background to conclusion. And so by background, tsetse flies are actually very unique organisms. They all spread trypanosomiasis, both male and female, all feed on blood. And they have a very low capacity for reproduction, and they only give birth to live animals. So unlike mosquitoes, they only give birth to live animals, which has been very deceptive in terms of control. And so looking at this diagram, not very clear from here, but you can see that the tsetse flies are almost everywhere in Africa, from East Africa to West Africa, and there are different species of tsetse flies, and they all transmit trypanosomiasis. And if you look at the purple area in Africa, that's the area where we have tsetse flies, and in those areas we don't have livestock. So essentially, tsetse fly has removed them from there. And in those particular areas too, where you have the green areas is where we have tsetse flies. In areas when you have livestock, in areas with tsetse flies. And of course, those livestock are either trypanotolerant or are kept under regular chemotherapy. And at the same time, the brown areas that you can see, there are areas, again, where we only have livestock. So you can see tsetse fly and trypanosomiasis have actually deprived a very big area of the most productive area of Africa from livestock and beef production. On the other hand, you see the brown images that we have there. those are the areas where you have the sleeping sickness. So you can see there's the area of mapping of the trypanosomes, stethyflies, and the sleeping sickness. And actually, coming out of that, what that diagram shows there, don't make clear, is that not all stethyflies actually transmit the human form of trypanosomiasis, but all stethyflies transmit the animal form of trypanosomiasis. So, so coming out of that, one of the aspects that has been used extensively in analysis or understanding the trypanosomes, the stethyflies, that they also respond to different aspects of light. Some respond very well to blue and brown and black colors. So this information has actually been used to develop tools for control of stethyflies. We have the traps. This is where the fly respond to these colors, together with odor from animal like preferred animal like buffalo, synthesized, then they can be able to be trapped. And we also have something we call targets. These are clothes that are essentially treated with insecticide that the stethyfly that mimic the actual host. So the stethyflies come, sit on them, and then they get lethal dose. So coming out of this, one of the initial discussions that we had was about how to sequence the genome of the stethyflies. So the initial phase of the work involved trying to understand whether we could be able to establish the different structures of the genome of the stethyfly that actually are able to determine which fly responds to which particular order and which genes are actually involved in this. And one of the key facts that we were looking at that particular point is, what is it that makes one fly? As I've indicated, I'll try to elaborate because I can see the writing here, it's not very clear. What the basic thing that we are trying to understand here is that why is it that one species of stethyfly can transmit trypanosomiasis, another one does not? Why is it that some species of stethyfly are attracted to particular orders and others are not? And why is it some tools are effective? And so our goal here was to see if we could be able to sequence all these genomes of the different stethyflies. And once we sequence all the genomes of the stethyflies, then come down and understand where the differences are, and then look at the molecular elements that can be used to decipher, to separate these species, and then use that to develop tools to do that. So, so out of that, we sequence first the first genome of the stethyfly, which we publish in Science. And out of this analysis of the first genome of the stethyfly, it encouraged us to sequence another 4 different genomes of different species of stethyfly. And when we did a comparative analysis of these particular genomes of the stethyflies, for now we have 6, together with Drosophila, which is actually the fruit fly, and Stomoxys, which is a biting fly, so that we could be able to compare these genomes and see whether we can be able to determine molecular events that are actually determining these things computationally. But again, we didn't see much of that coming out. And so when we did further studies looking at 3 different elements of the work or that we published, we realized something that was coming out, that we were not able to see most of these differences because of the potential gap in the genome annotations. So it's out of this that we now decided to come in and see whether we could expand the tool for control of stethyfly by integrating the different aspects that are there, by looking at whether we could be able to fill that gap and rather address that gap that was coming out in the genome of all these assemblies, most of them, and our focus was more on trying to see if we could be able to use the RNA sequencing method. So, so we set out to map the gaps, as I mentioned, that we saw in the genomes that were coming up, and trying to see if we could be able to find some genes that are associated with these gaps. And as usual, the central dogma of molecular biology is that we have from RNA to DNA to RNA. And so we felt that we could actually reverse the whole process from RNA to DNA. And so when we finally sequenced the entire process in the sequencing, we took the RNA, reversed the whole process back to DNA using AI-driven methods by informatic platform and try to identify all the genes that are associated with this RNA, because RNA by nature is complete. It covers the entire spectrum of all the genes that are there, including the ones that were missing. And out of that, we discovered first the gap that was there, and we are able to identify that actually we are able to do de novo assembly using computational methods. And then coming out of that, we did annotations. And when we finished all that, we actually found 202 new genes that came up. And out of these 2 new genes, 40 of them had orthologs or similarity with other genes in established insects like the mosquito, fruit fly, and sassafly. And this one had particular characteristics that were of interest to us. But what was interesting here is that we heard around 108, most of them were novel genes. And actually, some of them we actually discovered that were associated with responses of sassafly to either attractants or repellents. So we now came up with new genes that were able to tell us actually that that could be able to be used or applied in control or analysis or development of new tools for control of tsetse flies. So what we have now is we have the genes, and the next step that we are now looking at is trying to see or establish what we call validation through functional genomics. By functional genomics, we talk about taking the genes and probably silencing them or knocking them out in our flies and establishing whether they are really involved. And this one will actually inform us in improving our existing repellents and attractant technology. So the implications here, we have AI that has guided us through reverse genetics to identify new things that we want. It also helps in reducing transmission. By this method can reduce contact between the fly and the vertebrate host, and this can be interdicted in the region for facilitating cross-border movement and so on. And finally, we have a technology innovation. We have a technology that can actually be adapted across the industries, by the private sector, by the government. And we have developed a pipeline that can actually be used across almost all vector-borne diseases, because the same problem we see here is also there with mosquitoes and other tick-borne diseases as well. So annotation computation can actually be adapted, implemented to complete annotation of the orphaned genomes across all organisms that we have. And there you have my contact. Thank you so much.
Thank you very much for a nice presentation done within exact 10 minutes. Let us call upon the next presenter, who is Gladness Mwanga.
So while we are waiting for the PPT, let me ask in the room, how many are keeping cattle?
Can you use mic, please, because people need to hear your voice.
So while you are waiting for the PPT, let me ask people in the room, how many are keeping cattle? Wow, at least I have the audience. So my name is Gladness Mwanga. I'm a researcher at Nelson Mandela. And of course, I'll be taking you through a case study that we are doing. And I'm happy that we have people in the room that are keeping cattle. So, and this is the outline of my presentation, just to make you aware that the dairy sector actually is being contributed to a great extent by the small-scale farmers, and those are the farmers who actually own 2 to 3 animals. And of course, now looking at their small scale, being them the small scale, actually they encounter a number of challenges and factors which actually contribute to the low productivity. Because when you compare them to the other intensive farming, you might find them of the productivity is very low. And of course, this actually is contributed, as I've said, by many factors. One of them is the issue of the timely health data, and of course, having a decision support system that can help, because majority of them, they just rely on the physical observation of the animal. Oh, sorry. Yeah, I think I miscalculated that. Sorry. Yeah, so as I've said, the major problem is the issue of the decision, and of course, as we have also seen in the issue of them being able to have a critical information that can be able to make informed decision. And of course, as this is contributing, yes, the raw productivity, but at the end of the day also, it affects the economy and reduce the sustainability of the sector. And with this, the AI actually has a role to play as well. And for our project, our main aim was just to look on how we can integrate the AI, and of course for this, ensuring that we have a precision livestock farming within the region. So it's a case study that I'm going to share a little bit of what have come out. And we conducted this one at Tanzania, and of course we enrolled 100 farms, and with that we had more than 290 animals that we deployed the boluses. We are going to see what is that. And with that, we also had a monitoring of how the farmers are behaving and changing based on how they integrate or they interact with the system. So this is the bolus, the one you see on top there, though it's not much clear. And of course, the bolus is being seated inside the animal's stomach. And from there, the animal is linked directly to a farmer's phone. And the farmer can be able to know whether my animal had enough drink, enough feed, but also at the time that they need to inseminate them, the bolus can send an alert to a farmer's phone that my animal is on heat, so I need to inseminate. And this is also critical because insemination window is very short, so the farmer have to act timely. So looking at some of the results on the change and the behavior change of these farmers, and we are looking on how they respond back to what is being generated by these AI technologies. So looking at one of the behavior change that they had is them be able to respond on the alert, like the water alert, because at first when we deployed, they didn't know, and of course, that's how they were just keeping their animal, just giving whatever the amount of water to the animal without even knowing the quantity of the water that is needed by the animal. But after that, they started changing, and whenever they received the alarm, they increased the water or they increased the feed. And we are now looking at the data prior to the intervention and after the intervention. You can all see that even the milk production increased. So there was an increase of almost 40% of the milk production. So simply by them just reacting to the alerts that were generated. And of course, even you look at the feeding, though like these are the ones now who are responding back to the feeding. Now my animal has not consumed enough feed, let me increase the amount of feed. And of course, it was also reflected into their production. Of course, looking at their behavior change over a time, of course, we try to see those who have changed, who have managed to do a change and continue doing it, doing the best practices. While clustering them, we kind of identify they are the most winners in terms of even their production. The animal raising has increased their, their water intake, their feeding, and also they have enhanced in terms of the animal management. Those ones were more likely to have higher production than the other cluster. And this we also draw another point that even though for those guys who are keeping cattle, water is very important, and this is where we also find out that you can be insisting a farmer to keep feeding, but at the end of the day, the water is also important, as we have seen from the findings. Yeah, so in terms of the animal health, yes, we had different diseases that have been actually, it sent an alert in whenever the sense of disease. And of course, one of the disease which is more common to the dairy is the issue of mastitis. And from the graph, actually, at the left, actually, you can see that there was a number of alerts that are being generated by these devices. But when now the farmer has applied the intervention, in the middle there, now the alarm started reducing. And of course, because when the animals stay longer with the disease, that means also the farmer continue losing on the farm in terms of the productivity. So in summary of the results, actually in terms of the behavior change, we have seen that most of these farmers started now to make a change, and of course it was a reflection of what they were being observed from their mobile phones, that, okay, my animal need this, my animal maybe it's on heat. All of those ones actually were contributing for them to make a behavior change. And of course, also this, as I can generally say, is them now stopped reacting, and rather than now taking the proactive approach, and hence in terms of the precision livestock farming. So the implication of the study is contributing in terms of the science and innovation. Of course, we were able now to validate on the use of the precision livestock tools. And this one also can cut across, because at first we are not even sure whether it can also be used for the small-scale farmers, the people who have 2 to 3 animals. But in the end, we have seen the fruit of that. But at the same time, in terms of the economic transformation, as we have seen the increase of the milk production for those farmers who have now decided to move precisely in making their decisions. But at the same time also, in terms of the regional integration, we have tested this in Tanzania, and we also believe it can work across the globe, and of course, even for the sub-Saharan Africa, we are sharing, for the major part, most of the things are likely the same. So for the recommendations, our recommendation is for the government, first, to also incorporate the PLF technologies into the livestock sector. And of course, this one is very important, as most even of the document, now they speak of the veterinary. Now we need to also incorporate the issue of the PLF as part of the initiative for the livestock sector. But at the same time, to subsidize, there are a lot of technologies, but they are also very expensive for the other users to be able to adopt. But for the private sector, is also to ensure that they develop this technology or solution at a better cost, but at the same time to make sure that the technology really reflects the reality of the farm. Just to wind up, as a conclusion, we have seen that the technology, the PLF technology, really assists in terms of the production, but at the same time, we need to ensure that this technology are affordable and ensure that we train the farmers well. Thank you.
I think your time is up. Thank you very much. Take a seat. May I call upon the next presenter by name of Charlene. Charlene is going to present, do we have Charlene? Yes, Charlene is presenting on a AI-based smart seed zone recommender system for climate-resilient agriculture in East Africa. Charlene, as usual, you have maximum for 10 minutes. Please make sure that you utilize the time efficiently. The floor is yours.
Okay, thank you so much. Maybe as we wait for the presentation to come on, I know it's been a series of presentations in the past few minutes, so maybe you can all stand up. I always want people to be warm, and also the room is cold, so maybe we can stand up. I'll just use 1 minute for this. Let's all stand up and just stretch a bit. So I want us to spell coconut, okay? All of you love coconut, I hope. So we start with a C on this side, on the right side. So C, and then O, and then C on the other side, and then O, and then N, and then U, and then T, okay? So let's do faster, okay? All right, C, O, C, O, N, U, T. Okay, all right, let's start. Thank you so much. So, my name is Charlene Chepkosgei. I am a geospatial engineer by profession. I lecture at Technical University of Kenya, remote sensing and GIS, and also a founder of Women in Space Kenya, and as well a drone pilot. So I'm very passionate about utilizing Earth observation technologies to solve farmers' problems, and I would say that is in line with food security. So I'm going to present a project that we recently did. It's called GeoAI-based Smart Seed Recommender System for Climate Resilient Agriculture, and we did a pilot in Nandi County, that's in Kenya, and I'll be presenting on the background. Next slide. Okay, I think I need to use this. Yeah. So I'll go through the background, the problem statement, methodology, findings, until the conclusion. So with the background, we know that agriculture is productivity in East Africa, and actually in general in the world, remains vulnerable due to the shifting weather patterns based on climate change. And of course, this poses a major challenge for agricultural production. And now, of course, with the aspect of Earth observation using satellite technology, and now that we have also artificial intelligence that comes with geospatial data, it helps us now transform how we are solving our societal challenges. And when we talk about the background, and in terms of the problem, we can see that it all results from, of course, the climate change, where we are having erratic rainfall patterns, where we're experiencing high frequency and intensity variability in terms of how we're experiencing the weather. And the others, we've also realized that there's always increased heat stress on our crops. That is when the farmers plant the crops. And of course, this results to stagnation in terms of the staple crop. So it's exposing millions to acute of food security. And you can see we have a very big vulnerable gap, and that is mostly for our farmers. And you can see how it's really looking at if, in case we get to utilize Earth observation and AI. So the micro problem is that we have the technology, but most of our farmers don't know how to utilize this technology. And of course, most of us are researchers in this room. We have data. And sometimes knowing how to translate that data to even help the farmers and even help them really see the impact, and I think that has been part of the conversations that we've been having, has been is very critical. So we see that with the farmers currently, people who are planting, let's say the farmers, they have this mismatch between the seed variety. I mean, they can go to the agrovet shops and take a seed and plant, but sometimes it really does not fit maybe their current conditions, weather conditions, and also the type of soil that they have in their space. So we see that farmers lack that location-specific, data-driven seed recommendations. So most of them rely on generic seeds and this can sometimes result to crop failure. And now this is where Earth observation comes in place, because you get data from satellite image, you combine it with climate, and I think that's on the next slide. So the objective of the project was to integrate Earth observation, climate, and soil data sets into a geospatial analytical framework so that we are able to do seed suitability analysis. The second one was to develop machine learning models to do the prediction of this seed variety and looking at it in diverse agroecological zones. And then now we develop a decision support system that can help the farmers make best choices. So the solution was to use an AI Earth observation powered system where we are combining the Earth observations, soil data, vegetation, so that we're able to recommend to farmers and so that they're able to improve their yields. So the methodology is that we took the Earth observation data, mostly from Sentinel-2, combined it with local rainfall data, where we collect historical rainfall data, that's from CHAPS. We looked at the soil chemistry, we had the pH of the different locations, and then now we did vegetation indices, and then we put all that into an AI system recommender, and then the outputs become a very precise microzone seed match and detailed soil analysis, and also the solution was able to also provide with the farmers the best fertilizer that they can use. So the key result is that we were able to come up with a web-based application where a farmer, most farmers, some of the farmers can have smartphones or they're able to access internet. So they're able to log into the system web application. They can go to the location specific of where they are. They draw a boundary of their farms, and then they're able to click on it, and then it will give them the best seed recommendation. And what we did, we focused first on maize seed for a start, as it was a pilot study, and then now we'll be able to scale it up to other crops. These are the key result findings. So this is still part of the web-based application where we are able to see, you can see the map, and then you go to a county, then you can even zoom in where you see your farm as a farmer, and then you draw a polygon, and then it gives you like 3 varieties of seeds. I don't know if you can see it there. But the other way we noticed that, of course, most farmers don't have access to internet, and they are also based maybe where there's no internet, and maybe they don't have smartphones. So we went ahead to try to localize the solution into a USSD code. So they're able to tap on their SMS and just dial a USSD or an SMS, and then they get the information still for the seed variety. So you can see. Oh, sorry. So you can see we had to transform the web-based application into a USSD, which can help most farmers who don't have internet access. So you dial the code, and then it gets you to the sub-county where you are, and then you select the ward that you are based, and then it gives you top recommended seeds varieties. So you can go to the agrovet shop and ask for those seeds. And so the implication of the study was that this smart seed system recommender is very much aligned with farm conditions. When we went to do field validation, we found that the recommendation that we were getting from this system was actually based on also what farmers have planted. So it really showed the potential, and actually this can be scaled to support more farmers to better make better decisions, especially for their seeds, and even go towards also fertilizer utilization. So the impact of utilizing such platforms and actually utilizing AI and also, let's say, technologies like space technologies, which is Earth observation, means that we are able to create impact and transform the agricultural baseline by improving resilience. That is, we are able to reduce climate-related crop failure because we are able to suggest the best seed that will adapt to that climate. We'll be able to improve productivity by dramatically increasing the yields because we are taking the weather, the agroecological zone, the soil data, and all that, and also it's able to provide farmers with suitable fertilizer use. And of course, at the end, we are strengthening food security, both at the farm level and the national level.
Shireen, your time is up. Thank you so much.
Yeah, this is the last one. So we need to scale the solution, where we've just done a pilot in Nandi County, but it can be scaled to Kenya in general and also to other crops, and now to East Africa and Africa in general. Thank you so much.
Thank you very much. Please have a seat. The next and the last presentation, which was not in the program, but luckily we had another researcher, Bahati Joseph, going to present on harnessing AI for climate resilient agriculture, a case of picture-based insurance in Greater Bushenyi, Uganda. Please, if Bahati could do it within maximum for 8 minutes, we are already eating into the next time in the next session, so please.
Thank you. Protocol observed. My presentation is broken up into 2 parts. Please, would you start with the first part, the video, which is going to take us 3 minutes, and my presentation will also take some 3 minutes. The clip, please. The clip.
process of inundation, time of exposure, and the vulnerability. And also we calculate the probability of incidence threshold by that formula, and also we estimate the damage as concerned that formula. The system at Theta is designed like that. As the main finding is like the LSTM and the conv LSTM capture or help is like identify and simulate where the discharge as the coefficient of determination and NC was capped to 90%, and the error was, it's not visible. And why we integrated the output in the global map for 4 meter, it shows that the area surrounding the Tanganyika basin was inundated. Why we go to 10 meter? It shows like even the roads and some habitation was washed. Going to 12 meter, even the airport was washed. For the implication, we found that the study demonstrated that using AI architecture, such as conv LSTM combined with ERA5 and the LSTM, deliver skillful fraud forecasting in this area when there is no data. And also, it shows that this approach can be reproduced in other sub-basin in the region. Also, economically, when you improve forecasts, you reduce economic loss, and it protects the infrastructure and support a stable agriculture and trade activities. And also, it informs the climate resilience investment planning, and also it provides a shared data models. I mean, this for regional context and perspective. It may help to build a framework from transported basin with service of hydromet and also survey protection. For recommendation, we recommend to strengthen regional hydromet platform using global dataset and open source tools to promote transparent benchmarking and uncertainty analysis of models. Also to test the transferability of other sub-basin in the neighboring watershed in the region. We recommend also to partner with tech company and startup to develop operational dashboard, mobiles, and air warning apps in data services, and also could develop affordable services solution for national hydromet services to integrate basin fraud forecasting modules into national and regional air warning systems, invest minimum strengthening and observation network in this region to impact data collection and transport-area data sharing protocols, and also link these models into land use planning and zoning fraud area prone. I may end by that. Murakoze.
Yeah, thank you very much. I would like now to call upon Professor Caroline Mulinya to take the floor.
Thank you. Thank you. I think I already told you my name. I can't see my presentation. Thank you. My name is Caroline. I think I already said my name. I'm going to share on transforming smallholder resilience, an AI framework for climate-smart agriculture in Kakamega County, Kenya. That is the presentation outline. I won't talk so much about it because I'll have a background, problem statement, methodology, key findings, policy implications, conclusion, and Q&A. Background, I think all of us seated in this room know the issues of sub-Saharan Africa, in particular Kenya. Kenya is no exception. that we face extreme climate vulnerability due to over-reliance on rain-fed agriculture. And then secondly, the smallholder reality. In Kenya, most of our farmers are smallholder farmers who practice traditional knowledge, and in most times, the farming calendars have been disrupted by rising temperatures, shifting precipitations, and increased frequency of extreme weather, mainly drought and floods. And this has become a systematic risk in the sense that agriculture is the backbone of Kenya's economy, with 33% and GDP and 70% of rural employment. And then climate-smart agriculture can form a basis for a framework for this inquiry, and that is why we thought that we should be able to do this, because it can be able to help us to investigate and work simultaneously. Our problem statement, if you look at that map, you realize that artificial intelligence, particularly in market agriculture, has very small, or the absorption in Africa and maybe South America is quite low. If you look at the map, you can be able to see the red is low, the yellow is medium, and the green is high. That means that where we are, where Kenya is in many African countries, the absorption is, the absorption is quite low. And that is why this research was necessitated, because there's a need to move beyond just identifying the problem and towards validating and integrating context-specific solutions that can be able to address the interconnected goals of productivity, adaptation, and mitigation. It's very, very important that we can have a nexus of all this so that we can be able to understand and we have solutions to this. The research questions was, number one, to evaluate the technical performance of AI-driven interventions, localized weather prediction, computer vision for pest detection, and data-driven adversarial systems under small farming conditions in Kakamega County, Kenya. Objective 2, to assess the impact of these interventions on key agricultural outcomes, including productivity, resource use efficiency, and climate resilience. And thirdly, to identify the barriers and enablers of adoption, generating insights to inform the scaling strategies. Methodology, we had a mixed method design, whereby we combined quantitative analysis of AI system performance and agricultural outcomes with qualitative exploration of farmer experiences and adoption dynamics. The data sources were both primary and secondary, and I don't think I really want to belabor on that. We had both quantitative and qualitative, and they were analyzed. Qualitative particularly was analyzed thematically, whereby we had various themes to be able to tell us our findings. These were the key findings. Machine learning models significantly outperformed conventional forecasting methods. Rainfall forecast accuracy at a 3-day lead time improved by 35% from the previous, and temperature forecast showed 28 reduction in mean absolute error. Forecast improvements were greatest during critical farming periods, that is planting time and peak growing seasons, when accurate weather information has highest value for farmer decision making. Implications of these findings to science: we can have predictive modeling, whereby we can be able to demonstrate LCTM, neutral and network outperformance traditional models, achieving a 35% improvement in rainfall forecast accuracy. We can have diagnostic tools, development of a computer vision system with 92% average accuracy for pest and disease detection, particularly 94% for maize lethal necrosis, improving its scientific reliability. Contribution to economic transformation, we had increased productivity, boosted crop yields significantly, maize about 23%, sugarcane 18%, directly increasing farmers' incomes. Then we had enhanced efficiency, reduced input costs, fertilizer 1.2%, pesticides 18%, and improved resource management, water efficiency, time saved, and pest scouting. And contribution to economic transformation, also we have risk mitigation, cut crop losses from pests by 25%, creating more stable and reliable farming enterprises. Then adoption to modern practices catalyzed the uptake of climate-smart agriculture, e.g. improved seeds and conservation agriculture. Implications of the findings to regional integration, we can have scalable solutions whereby AI models trained on local data can be deployed across borders to address shared threats in similar agroecological zones. Then you can also have harmonized systems that will provide the foundation for regional early warning system for weather and pests cross-border data sharing. Contribution to regional integration, again, inclusive growth, we can have highlight critical equity gaps, e.g. gender yield gap to inform triggered regional policies to ensure balanced economic development. Policy and innovation recommendation, there was a need to invest more in rural digital infrastructure. I think this had been said many times yesterday, that we really have to look at our rural setups. And this can be both by the national and county governments prioritizing expansion of mobile network coverage. Number two, we can strengthen extension systems. As much as we have this, and I think yesterday as I sat in this room, I listened to human capital and infrastructure. So there's a need that we can be able to have human extension services and policymakers so that they can also give us the extension services. Thirdly, develop data governance frameworks. We should have clear policies governing agricultural data ownership, privacy, and benefit sharing to protect farmer interest while enabling beneficial data for AI system. And then support gender digital inclusion. As you noticed, particularly the female, most of them, even if they have the phones, they might not be able to use them properly, or so it's important that we support the gender digital inclusion by having our female farmers, particularly the smallholder ones, being able to use these gadgets. Lastly, we just must embrace technology. Thank you so much.
Thank you, Professor Caroline. I would like now to call the final presenter, Senior Diop. You have your 8 minutes.
Thank you, dear moderator, for the floor. My presentation will be the medicinal plants and nutritional floristic potential of sacred forests in Kaziba landscape, Eastern DR Congo, and identification was done by using digital network platform and digital database. this is a presentation plan. And we know that DRC is one of the solutions for the problem of undernourishment, which is in the world, because DRC has a largest flora diversity, which is made by no timber forest products, and this no timber forest product have been reported as food and medicinal plant. But in DRC, there is a problem of the documentation of these plants and the development of strategy which can conserve this plant. In Kaziba, the problem are three. One of the problem is the lack of development of forest resources, and the other problem is the poverty and the problem of forest degradation, which can cause the loss of these forest plants, which is important for the population which is poor. And this loss can cause the rarefaction of this plant, which can cause also the loss of the traditional knowledge. And in this study, we asked us what is the diversity of plants which is in that relict forest, and what is the factors that influence the accessibility. And after we suggested to know what are the measures which can be put in place in order to protect these plants. There is some hypothesis. We know that Kaziba is located in the Rift Albertine region, and this region is made by a large biodiversity, and we think that in this forest there is some food plants and medicinal plants, and also we think that availability of this plant have declined because of human pressure, and also the implementation of some appropriate measure can help to protect this plant. We have done an ethnobotanical survey, in which we have used 96 persons for the survey. After we go on the field to identify the plants, and we use the digital mobile application, which is called PlantNet, which have been validated to be used in preliminary identification of plants. And after, if percent is less than 50%, we can use some laboratory to identify the plant. We use laboratory of Université Officielle of Bukavu to identify plants which have not been identified by the app. And also, we validate the name of plants using an online database which is appropriate for the tropical region. And the use of plants have been also identified by using database online, for example, Prota and another database which is called ethnopharmacology, which have been used. This is a forest in which we assess our plants, and this is a methodology, as I say. We have after validate the plant, we have done a literature review to validate also the use that have been given by population, and after we use a multivariate statistical package to analyze the forest which has the largest biodiversity than the others. And after, we look how is the knowledge among the population by classify plants which are well known and those which are not well known. We assessed 53 plants, and in that 53 plants, there was 23 food plants and 43 medicinal plants, but among the 53, there was some which are used as medicinal and food at the same time. And we have found that the knowledge of the plant, it have been lost. Plants are well known, but the plants have been deforested. Forests have been deforested, and this caused the loss of some plant in the forest. And food plants, majority of plants used for food are used for leaves, for the fruits, please. And plants which are used in medicinal plants are used for their leaves in majority. But the population told us that in this time currently, plants are not very available in the region. And the factor that causes it's, for example, cropland conversion, for the forest is converted in croplands, and also bushfire and extraction of firewood. These are the main problem which are there. But the forest.
Please use 1 minute to conclude.
Thank you. The forest which is the largest forest is the forest of Luampango and Kamano, which is the largest forest in this area. And these largest forests have a similarity of species used in food and medicinal use. For the measure that population said to protect the plants, they said that we can educate population to preserve the forests and also to restore the species which have been deforested. And also population have doing valorization of that plant. For example, there is a plant like Mirianthus holsti, which is a plant which product fruits, and this plant is also a medicinal plant, and it have been domesticated in this area, and it gives a good product. It means that for the implication of this result contribute to understand the importance of this traditional knowledge in this area for relict forest, which is sacred also, and it shows that it is important to preserve this plant in this area by doing transmission of knowledge to local population. And also, it is important to do governance of this forest, which are important for this poor population. For recommendation, it is important to protect this forest as protected area by using a park management, which is one of the model which is used in DRC for forest management. And also, it is important to do domestication of this plants in order to preserve plants which are important for this local population, which is poor. And the other thing is to do the transmission of this knowledge, traditional knowledge, in population. For the key message, it's important to know that traditional health is one of our culture in Africa and in ERC in particular. And it's important to develop, for example, for scientists which are on this health domain to develop a board which is important for East Africa. And for AI and this digital tool, it's important to develop a digital database which remain for native plant in all the East Africa. Thank you for your kind attention.
Thank you very much. Another round of applause to Diop. As we come to a close, we'd like to confirm a final confirmation. Might Marty Rita be present? No. So we take this opportunity now to, I will write on the protocols established. In the interest of time, because there's pressure of time, I will request the photographer to just come over and take this photo of these very interesting presentations. Would have loved to listen to the Q&A, but we would want also to save time for the next session. So we may arise and take the photo. Thank you very much. I would like to hand over the session to the next moderator.
Nakuze numva inkuru ko hariho umugabo witiraga yasaga nk'umuntu mushya mu cyaro cy'iwacu we yasaga nk'unaniwe kandi yari afite icyaka ajya kugura amazi kubw'amahirwe yarageze hari abacuruzi ntiyari afite impamba kandi yasaga nk'umugenzi koko yari umugenzi ntiyari umutunzi
most of the economies, especially in no-resource environment. And when you look at the reports from different organizations, basing on my country, Uganda, agriculture plays a crucial role, and coffee is one of the key export commodities that contribute 3 to 4% on the general GDP of the economy. According to the reports from International Coffee Organization, agriculture provides income to 12.5 million farming families, and this helps in shaping the socio-economic lives and those regions that are producing coffee. So despite its relevancy in the economy, forecasting tools that are reliable to detect the prices of agriculture in the future remain unlimited. So when you look at the background, it shows that the prices are highly volatile, especially regarding to market prices for agriculture. Therefore, this creates a need for more accurate AI-driven models to forecast the prices of agriculture products, especially coffee. The problem statement: unstable market prices for agricultural products in a resource environment pose significant challenges to many stakeholders. These include the farmers, traders, and then the policymakers that are vulnerable to the highly volatile prices for this particular product. And therefore, the study investigates how the advanced time series analysis and then AI models can bridge the gap by coming up with a model that can forecast the price of these products in the future. This translates me into the objectives of the study. The main objective of the study was to develop a market price prediction model for agriculture products, specifically looking at coffee as a case study, and then looking at Robusta as a type of coffee, because from Uganda, 80% of the coffee farmers, they go for this specific type of coffee. Therefore, with the objective, this objective was achieved by carrying out numerous technical data processing, data pre-processing, and then collecting data from different reputable organizations. The methodology, this is the design science of the methodology. The study was informed using Sanders et al. 2009 and then 2019 Research Onion, which provides a structured framework moving from the philosophical assumptions to data collection and then analysis techniques. The philosophy which was adopted in the study was positivism, which assumes that variables or phenomena can objectively be quantified or measured using empirical data. And then the strategy which was used was the experimental modeling strategy, because different models were developed ranging from the statistical models to the advanced AI models. They were all tested and evaluated under the same environment. And then the key evaluation metrics of mean absolute error, mean squared error, root mean squared error were used to evaluate the performance of these models. And then after the evaluation, it was observed that the outperforming model, it was an AI model, the LSTM, with the lower forecasting error, implying that its prediction accuracy was relatively high compared to the other statistical model, SARIMA, which catered for one variable, and then SARIMAX which catered for exogenous variables, and then the multivariance variable. The data sources that were used, they were collected from 4 reputable organizations within the country and then outside the country. The data structure comprised of 32 years with monthly observations. And then when I look at the key findings in the study, it shows that the univariant LSTM model outperformed the rest of the models with the lowest forecasting error. So when we proceed with the implications on the science and science innovation, the AI models show the strength and the effectiveness of its ability to capture the non-complexity and the nonlinear patterns that are found in the market dynamics. Then with the economic, these models that can forecast the prices for these agricultural products can help farmers to make informed decisions at the regional level. The model can be adopted to different countries, not only specifically Uganda, and then it can be extended to other agricultural products, not looking at only coffee, because there are different products that are grown in different regions. Then recommendation, research, technology, and community. There is need to sensitize and collaborate with different disciplines about the use of AI and this hybrid model while accessing high quality data and then integrating these models. Then when it comes to the private sectors can always integrate these AI reliable forecasting tools into their systems to provide real-time market insights to the stakeholders. Then for the government, there is need to strengthen agriculture data system and use predictive analytics to provide better planning and then protect the key stakeholders in this sector. In conclusion, I don't know what happened, but in conclusion, the findings show how best the AI models outperform the rest of the models, regardless of having come up with a hybrid model. I was surprised that it was one of the worst performers compared to the rest of the models. This shows that the complexity of the model does not always guarantee its improved accuracy in terms of performance. So the univariant LSTM outperformed, and it shows its ability to capture the complexity and the nonlinear patterns that are found in agricultural price data. Allow me to stop here due to the interest of time. Thank you for your time, and thank you, moderator.
Thank you. A round of applause. Let's now call upon Rehema Salum. Over to you. You have 10 minutes.
Good evening, ladies and gentlemen. My name is Rehema Salum. I'm data scientist. I should have presentation. Okay, my name is Rehema Salum. I'm a data scientist, and I write this work with Dr. Salome Malo, which is my co-author, from University of Dar es Salaam, Tanzania. And my research title, I'm in machine learning approach for predicting rice production in Tanzania by integrating both economic and environmental factors. Okay, so this is a presentation overview. I will go to background, problem statements, methodology, key findings, implication, and lastly conclusion. Starting with background, as we all know, rice is key crop in Tanzania and in East Africa in general, and it's the major food crop. And accurate prediction of the rice, it helps to ensure food security and also planning. Environmental factors such as weather, soil, vegetation index have been influenced rice production and widely used in prediction of rice production, but limited focus on economic factors, specifically macroeconomic factors in predicting rice production. So in the problem statement, as I said, as increasing the demand of rice production, it poses the major challenges for global food security, making accurate prediction of rice production essential for effectively planning and decision making. Machine learning has been widely used in predicting rice production and shows the improvement in the prediction. And environmental factor has been also been used in predicting rice production. Unfortunately, limited study has been incorporated economic factors, specifically microeconomic factors in predicting rice production. So this study is going to incorporate macroeconomic factors in predicting rice production. So the objective at first is establish macroeconomic factors that can be integrated with the environmental factors for accurately predicting rice production, to train the machine learning model, algorithm for predicting rice production, and lastly, to evaluate the performance of the machine learning model. Methodology, study design, I use computational experiment design, where I use machine learning algorithm, and analytical method, I use quantitative approach using random forests, XGBoost, and gradient boost models, and evaluating metrics, I'll use R-square, root mean square error, and mean absolute error. So I use different data sources from different sources, whether I take them from terraclimatic, vegetation index, which is normalized difference vegetation index, I take it from NASA GIMS, where it's globally, it's monitor agriculture's applications, and rice production and area of harvesting I take from National Bureau of Statistics of Tanzania, where they keep every year data. Economic factor, specifically economic, which is like price of rice, price of fuel, price of fertilizers, and so on, I take from different sources such as World Food Program, Tanzania Fertilizer Regulatory Authorities, and Energy and Water Utility Regulatory Authority, EWURA. But due to data, the gap of the data for some economic factor, I will only concentrate with the rice price and the price of the fuel. This is my model workflow. I combine the data set from different sources, including weather, the vegetation index, from satellite data, soil data, and economic factors, and the rice of production and area of harvested. After combining, I split my data set in training and testing, where 8% of the data used for training, 20% of the data used for testing. After that, I incorporate those data into, machine learning algorithm, which is XGBoost, gradient boosting, and random forest, and then evaluate the model performance. So this is my results. The key finding is that incorporating environmental factors and the macroeconomic factors to lead to high accuracy of R-square compared when environmental factors only incorporated in the model. And random forests outperform other model as their R-square is higher than the other model, which is XGBoost and gradient boost. Same to root mean square error. Random forest had the small root mean square error compared to other variables, other model, and environmental factors and macroeconomic factors has small error compared when environmental factors used alone. Implication of this study, at science, I'm encouraging the application of ensemble learning, which is random forest, and other machine learning techniques in solving in real-world complex problems. And in economic transformation, understanding the inverse relationship between the prices and the production enables stakeholders to anticipate market trends, adapt production strategies, and implement intervectors and enhance productivity. For regional integration, it supports cross-border agriculture planning, inform trade policies, harmonization, and strengthening food security across the region. Recommendation, In government, first of all, they have to support data infrastructure. As you can see, many of the data were missing. That's why I only concentrate on the lice price and the fuel price. I would incorporate the price of fertilizer, seed prices, and other macroeconomic factors, but due to the data remits, I incorporate only 2 variables. So the government should support the data infrastructure, but also should create in policies that can harmonize or stabilize this price, to ensure that there is no volatility of the prices. For private sector, they should adapt and invest in data-driven approach for their prediction technology to optimize investments and supply chains and the agriculture operation. For research technology and innovation community to encourage use of the advanced machine learning model to improve prediction accuracy across lice and other agriculture products. Not only lice, could be maize and other agriculture. So my key takeaways for this study is rice production is not only influenced by environmental factors, it's also influenced by economic factors. So integrate this, improve the prediction accuracy. But also using advanced models such as machine learning enhance prediction accuracy and supports better planning and decision making. But also stronger policies are needed to effectively manage price volatility. Lastly, this study highlights the importance of macroeconomic factors in production and establish a foundation for extending this to other agriculture, maize and other agriculture as well. Thank you for your attention.
Thank you very much, Rehema. We now listen to the final presenter, Dr. Kasiana. Over to you, 10 minutes.
Okay, good evening, everyone. My name is Dr. Kasiana Blasius Luiwa. I am a postdoctoral researcher at the University of Pretoria in South Africa, but I am also a lecturer at Mkoa University College of Education, University of Dar es Salaam in Tanzania. So I am presenting a paper with titled AI Enhanced Climate Monitoring to optimize an insulated solar box cooker using thermal energy storage materials. This paper was collaborated with my undergraduate student. So my presentation will cover the background of the study, the problem statement, methodology, key finding, the policy implication, and the conclusion. Starting from the background, the problem relies on the extensive use of the biomass for cooking. And recent reports showed that worldwide, about 3 billion of people still rely on the use of biomass, such as firewood and charcoal for cooking. So to solve this problem or minimize the problem of using biomass, clean cooking technologies are essential for achieving the Sustainable Development Goals, which are related to the climate, health, affordable clean energy, as well as life on the land. So there are some AI models, regression models, artificial network, and other models which are used for optimizing the renewable energy. But few studies have incorporated the use of AI models with the local heat storage materials. So in this study, we designed a very simple solar box cooker, which was integrated with the sensible heat storage materials locally available, like the common salt, which is sodium chloride, stones, as well as sand. We also used the insulation so that heat can be retained and used even after sunset. So the problem statement is about the extensive use of biomass, as I said. There are several options to minimize the use of biomass for cooking. So the first option is the use of liquefied petroleum gas. But remember, this one also still relies on burning of fossil fuel, but LPG also is not a renewable energy. So it's a clean source of energy, but then it's not renewable. Another alternative can be the use of electric cookers, but this requires batteries for those who are on off-grid areas. So it can be an alternative for the clean energy, but then it's limited for the people at rural areas who are not connected with the grid. Another option can be the use of solar cooking, but then the intermittent nature of solar radiation limits cooking during off sunshine hours. So what is the solution? The solution is the use of solar cooking, but should be combined with the heat storage materials. Because in Africa, we cook in the morning, afternoon, and evening. We don't cook like once per day. So to solve that problem, we need the heat storage materials so that heat could be retained and used when needed. So the challenge is the challenge is developing the system, which will be simple, using the local heat storage materials. So we have 3 objectives. The first is to design the simple solar box cooker, which will be integrated with the heat storage materials and insulation. And the second objective is to compute the cooking power for each of the heat storage materials so that we determine which materials is suitable. And also the last objective is to optimize the solar box cookers. So we used the third-order polynomial regression modeling, which was implemented in Python. So the methodology of the study was largely experimental, and on the right-hand side showed the design box cooker. So we had 2 boxes, one bigger than the other, and this cooker was placed inside the small box, and then we tested each materials separately. For example, we started with sodium chloride with sawdust insulation, and then sodium chloride with the rice husk. So we tested for each materials with those 2 insulation. The data sources, we measured the ambient temperature and also the temperature of water using each of heat storage materials. And analytically, we analyzed the data using the regression modeling, which is shown there. The T is the predicted temperature of the system, and the constant B naught is the linear temperature of the system. And then and then the beta 1, beta 2, and beta 3, those were constant, and we ended on the third-order polynomial regression because going further to the 4th order or 6th order, there was a slightly difference on the R square and the mean absolute area and the root mean square errors. So on the picture, it shows the heat storage materials. As I said, we used the stones, normal salt, and sand. And on the insulation, we used the rice husk and sand. So the findings, here I summarized the optimal temperatures using the heat storage materials for each insulation. And from the figure, it shows the sodium chloride or the common salt outperformed other heat storage materials. And from the cooking power is proportional to the temperature, so the higher the temperature of the materials, the higher the cooking power. And also the model performance, we analyzed the pooled data set for all the materials, common salt, stone, and salt. So we computed the coefficient of determination, and it showed that the rice husk performed better than the sawdust. And the mean absolute error and root mean square error, we got the values somewhat high, but that might be contributed with the thermocouple limitations. This instrument has some errors, as well as the ambient variability, because these experiments were performed outside. And remember, we had 6 experiments, and each experiment were performed on a certain day, so the ambient variability might have contributed, as well as the approximation of the polynomial regression. So implication of the finding for the science, technology, and innovation, it enhances understanding of the solar cooking and promote innovation in sustainable cooking technology for future research. And regarding the economic transformation, optimizing solar box cookers offer cost-effective, clean cooking solution, and also lowering energy costs and improve livelihood. For the regional integration, regional cooperation by showcasing the solar cooking technologies, fostering knowledge, and also promoting sustainable practices across similar climate. And regarding the recommendation for the research, technology, and innovation, this study promotes further studies to refine solar cooking technologies and explore new materials, and preferably local heat storage material, which will be widely available. And for the communities, to educate communities on the benefit of the use of the solar box cookers to encourage sustainable cooking practices. And for the private sector, to encourage business to create affordable solar cooking solution and distribute them in underserved areas, like in rural areas where the extensive use of biomass is observed. And also for the government to implement the policies to support the adoption of renewable energy technologies, including solar cooking. So in conclusion, solar cooking can be done by using simple solar box cooker, as we have designed also our system, by integrating also with the heat storage materials. This is to enhance cooking, retain heat for cooking when needed. And also the study highlights the potential of solar cooking technologies to improve the energy access, particularly in off-grid or rural areas. And AI models, in our case, we used the polynomial regression, which was implemented in Python, can be used for optimizing solar thermal system and determination of the best heat storage materials for cooking. Thank you for your attention.
Thank you. A round of applause to Dr. Kasiana. We have a final presenter, Samuel Kamau. Over to you, 10 minutes.
Can everyone hear me?
You may want to get closer to the mic or something.
Can everyone hear me now? Okay, awesome. Thank you, moderator. Thank you, everyone, for attending. My name is Sam Kamau. I'm an engineer, and I'll be presenting on improving city resilience with AI-assisted adaptive zoning. Brief overview of the research. We'll first go through the background, then we'll walk through the problem statement, and then look at the methodology, look at the findings, look at the policy implications, and then conclude. So the background of the study is essentially the rapid urbanization across East Africa is causing a lot of infrastructure stress. And this, combined with increased exposure to climate risks such as flooding and heat risks, creates significant vulnerability across cities, across the infrastructure, the food systems, as well as the economy in general. The second thing is that the growth of informal settlements, especially in just cities in general, also increases social vulnerability. And then finally, zoning in and of itself, at least at this time, is either non-existent for some of these East African cities, and then alternatively, if it's not necessarily existent, it's static and reactive, which creates fragility in the cities themselves. So there is generally limited application of AI in essentially creating adaptive urban governance, and that is what the research is focused on. So as I mentioned in the background, zoning right now is essentially looked at as a fixed regulatory system. So when you're zoning a city, essentially what's happening with modern urban planning or with governance is you choose the different sections of what's going to happen in what zones in the city, and that's it. Maybe zones are reclassified once every 10 years or so, if not longer, if not ever. However, the urban systems themselves, or the cities, are rather dynamic and are operating in an uncertain environment that's generally prone to shocks. And so there are no tools, at least at this time, to implement scenario planning, to essentially look at the long-term planning of a city and to increase resilience outcomes, and just generally to think of policy trade-offs as well. And then the other thing is that also informal settlement growth remains poorly modeled. So a lot of cities aren't necessarily actually modeling the growth of the informal settlements. They just know that those settlements are there. So in this study or in this research, we were, first of all, are going to be, or what we did was to develop a spatial environment for urban systems. What that spatial environment does is it enables us to look at zoning as a control system that can update itself, with AI as policy essentially evolves over time. The second thing is that we wanted to make sure that we're modeling the approach, or the modeling approach that we're using enables us to understand how we're optimizing infrastructure, and how we're essentially looking at the modeling of risk as well as informal settlements. Finally, we wanted to make sure that we're also designing AI-assisted zoning as a framework, and then using that framework to essentially look at the impact of certain policies on risk exposure, on the growth of informal settlements, and on infrastructure accessibility across each city. We ended up doing this across 5 cities. So that's Dar es Salaam, Kigali, Nairobi, Mombasa, and Kampala across East Africa. And how the study looked like for each city was that it was an agent-based environment with reinforcement learning. So it was a hybrid model between those two aspects. So agents in an environment that essentially models the city, and then reinforcement learning to optimize the way zones are established or are labeled across the city. So the data sources we used, there are some cities that do not necessarily have zones, or do not have clearly labeled zones, where others do in the 5 cities we were looking at. So we ended up creating a uniform baseline using data sources like Google Earth Engine, satellite data, OpenStreetMap for infrastructure data, world population for population data, and then we also looked at Google Open Buildings to essentially understand how buildings are laid out across the city, as well as the density of buildings across each of the city's grid spaces. So when we think of the analytical methods, or when we think of how we now modeled the data from those sources, we essentially implemented feature engineering for the spaces, or spatial feature engineering, and then we used clustering and an informal score to be able to label the land use clusters. And then finally, we used reinforcement learning for the optimization of the zoning over time. And this modeling was implemented first in essentially Python to be able to get, or to be able to implement the environments. And also we used Gymnasium and stable baselines as our reinforcement learning environment, and PPO specifically as the reinforcement learning algorithm implemented in PyTorch. And so we apply these methods essentially to simulate decisions. So think of the reinforcement learning agent as like a planner who would want to be labeling different zones across the city. We then essentially, after running the simulation, were able to find a few key results, and the ones that we want to focus on, we have three very focused ones. The first one is that adaptive policies generally reduced risk exposure across flooding specifically, which is what we modeled, and also across just informal vulnerability. So one of the things you realize when you look at cities is that a number of the informal settlements end up being close to water and at points of low elevation. So the people who are the least, who have the least financial capacity to respond to climate shocks or to respond to flooding end up being grossly affected as compared to other groups. So adaptive policies or adaptive policy design, at least in this case, reduces that risk exposure. And then the second thing is that informal settlement growth can be mitigated, as I was mentioning. If you are able to identify those specific zones, then you're able to create either incentives as your urban governance partners, or as developers to either create affordable housing, or to invest in infrastructure such as improved drainage in those specific areas, so that those informal settlements can be mitigated to a level, or at least their vulnerability can be mitigated. Finally, we also realized that trade-offs emerge between two things: accessibility for the infrastructure across the city and risk. So there are some situations where, for example, I'd say in Nairobi, I don't know if you guys have seen, but it was flooding recently. And you realize we have like huge highways in some spaces, but simply increasing accessibility does not necessarily mitigate risk. Those highways enable a lot more people to travel to the central business district, but if there is poor drainage across the central business district or even along the highway, all that creates is a lot more people in the flood when the flood happens. So we are going to walk through one final example of the key results and findings. So this is essentially a time-step grid of what one reinforcement learning environment would look like. And on the left side, you see what you see on the left side would be the reinforcement learning agent relabeling certain regions. And on the right, we have the control, which is just the static zoning approaches that actually happen now. So this example is specifically for Kigali. So when we look at the first timestamp, as you can see, they look relatively similar, but as we start to move along, you see that the AI agent or the reinforcement learning agent start to label these spaces kind of outside the city, and we'll get to the legend, but essentially it starts to find ways to either rezone some areas as commercial or residential areas. And I think that part of the reason the reinforcement learning agent was able to do this was to decrease the infrastructure stress for the central part of the city. So the white boundaries that you're seeing is actually Kigali, but we modeled a larger area because we wanted a buffer to be able to look at spillover effects. So as you can see, as we go through the timestamps, it continues to zone other areas into commercial and residential space. And then the other interesting thing is that You'll see bits
You
of
have,
green.
you have 1 minute to conclude
Sounds
your
good.
presentation.
You'll see bits of green with the blue on the outsides, so it's also able to essentially label green space. So it is also zoning specific spaces for green space, and that also improves the resilience of the city in general. So that's the final timestamp. That's the difference between both approaches, and as you can see, the orange is actually just the amount of vulnerability, and this is what that looks like on a graph. So you can see the informal rate sharply decreasing with the AI-assisted adaptive zoning reinforcement learning approach. You can see on your bottom right, infrastructure accessibility also increasing significantly. Implications, I'll quickly go through these. So for innovation, we essentially need to be able to, it is clear that AI-assisted adaptive zoning does help with the optimization. We're also able to understand that over time, we are able to do a few things for either the public and the private sector, as well as for the government sector. I think I'll walk through those on the next slide. This slide is just to essentially talk about the implications and to show that policy trade-offs can be made by AI-assisted adaptive zoning. So policies or recommendations, so for at least the innovation and research community, which is people here, there are a number of open research problems in this space that can be improved upon. Number two is that there is the opportunity to be able to invest or to develop products around urban analytics in general and to invest in these. And then for the government sector, there is the opportunity to understand that, one, these are methods that can be used to optimize infrastructure planning quite effectively and efficiently at a cost that justifies the decisions and that is optimized for the most impact because you can model those scenarios. Conclusion, so as I said, zoning can be imagined as a dynamic control system. And sorry, I don't have my glasses on, so I'm actually struggling to see some of these slides. But we are also able to look at policy and planning, as well as other decisions under uncertainty using AI-assisted adaptive zoning quite effectively. And AI adaptive zoning can help with infrastructure planning, with scenario planning, with planning for policy, and can also be used to be able to understand the effects of certain decisions under stress, and to be able to experiment without necessarily having to make the upfront investment to actually build the infrastructure in order to be able to understand its effects over time. So thank you. If anyone wants to connect, that's my email, sam@vibraniumdb. You can scan that for LinkedIn. I don't think we have time for that, though. Thank you so much, moderator. I'll say thank you.
Yeah, thank you. Thank you, Samuel. This brings us to the close of our session this evening. You'll bear with us, we are past time, and we will continue riding on the existing protocol. We just request the photographer to come over. Thank you, presenters. We can take this photograph in memory of the very interesting presentations that you have made. Thank you very much. The presenters are around in case of a cup of tea, can get clarification, questions and comments. So I believe there is somebody who can guide us from here moving forward. The session is over. wish you a good evening. We'll see you tomorrow morning. Thank you.